All right, we've been looking at exponential growth and decay, right? Just a little bit. We'll get a little bit more into it here. Basically, what's an exponential function? You take a starting amount of something and do what with it? Multiply it by something. How many times do you multiply it by that something? Huh? Where do you find out, if you're looking at an equation, where do you find out how many times it gets multiplied? In the exponent, right? Okay, that's basically all this. So let's look at a couple of these things here. And by the way, we also kind of touched on the rate of change. Remember yesterday we made a table. Some amount was increasing exponentially, right? And do you remember, was it going up by the same amount, like adding the same amount each time? Or not? I think it went from like it was doubled, right? The one went from 3 to 6, right? Then to 12, then to 24. Were you adding the same amount each time? No. Right. So was there a constant rate of change? Okay, what was the amount that you were adding every time? If we did, yeah, right. So, for example, we had a 3 got doubled, then to a 6, then to a 12, then to 24. What am I adding to get from 3 to 6? 3. What am I adding to get from 6 to 12? And then from 12 to 24. Is that a constant rate of change? No, the rate of change is increasing as you go, right? Okay, so it's not linear. Clear all that out of there. Okay, so exponential functions are not going to have a constant rate of change. Okay, they're either going to have an increasing rate of change or a decreasing rate of change. So there's some examples here. We have this function, f of x equals 8 times 2 to the x. Let's evaluate f of 2. So it would be 8 times 2 squared. What's 2 squared? 4. And 8 times 4 is 32. F of 0. So it would be 8 times 2 to the 0. What's 2 to the 0? 1. So what does this evaluate to? 8. And f of negative 1. So this would be 8 times 2 to the negative 1. What do we do with that exponent, guys? We're going to bring it down and make it positive, right? So that's 8 over 2 to the first. I don't have to write that in there, right? And what does that end up being? 4. Okay? So we have some different numbers to work with. And now they're going to ask us to calculate a rate of change. You remember how to do rate of change? It's the second output. How did I say it? It was the new output minus the old output over new input minus old input. Right. So here's the inputs, right? From negative 1 to 0 that they want the rate of change over. Okay? So we need to do, right, we need f of 0 minus f of negative 1, right, over 0 minus negative 1, right? Remember doing that? But luckily we already have what f of 0 and f of negative 1 are up there. So what does that give us? What's f of 0 from up in part A? So it would be 8 minus what? 4 over, well, that's 0 plus 1, right? Which is 4 over 1, or 4. So this function between x values of negative 1 and 0 has an average rate of change of 4. Okay? Now they want us to do a rate of change between what two x's in part C? 0 and 2, right? So this would be f of 2 minus f of 0, yeah, over what? 2 minus 0. Well, what was f of 2? So that's 32 minus 8 over No, not negative 2. 2, right? What's 32 minus 8? 24. 12. Yeah, you got to do new minus old over new minus old. Right? That's just for that event what we're talking about, just like the slope formula, which is kind of like this. Right. Don't confuse you. When you're doing the rate of change like this, you do it the new minus old. Okay? Yeah, eventually you will, right? But, so this very same function between -1 and 0, the rate of change is 4. It goes up 4, right? It rises by 4 units. But then from 0 to 2, it rises by what? 12 units. So it goes up 4 and then up 12 over the next interval. So that's not a constant rate of change. So it's not linear, is it? Okay? If it was linear, these would both be the same, yeah? So if we were to graph this, it can't be a straight line. What's it going to be? Curve, yeah? Okay. So what does comparing answer from B and C tell you about the function? The rate of change is not what? Huh? Right. The rate of change is not constant. Okay? So that means it's not linear. It will not make a nice straight line. Okay? Is it bothering you? Yeah. All right. So what does the rate of change do? Huh? What does it do as you move along? Increases. Okay, the rate of change increases. It doesn't stay the same. It would be kind of like a linear function would be driving your car at the same speed, like down the highway, right? This function would be like doing what with your car? Accelerating, speeding up, right? Okay. What? Yes, what? Sure, yeah. Exactly. Now, using your calculator, they want us to sketch this function, so we're going to put it in there, and they want us to use the window here. You guys remember how to change your window? You see the numbers they have here? The minimum x, maximum x, minimum y, maximum y. So we're going to put that function in your calculator. Yeah, no, it's right here. So just follow along. Yeah. So hit this little scratch pad button. You might have this screen, right? Hit it again. Now you have the graph, right? Yeah. Now push this button that says tab. Well, let's not put that in. Let's change the window, right? You see the window in the book? Yeah. It goes from what? -4 to 4 in the book? Anna? Yeah. In the book. And this goes from what? -10 to 10. And this doesn't match up with the y in there, right? So we can change that. If you're on this screen, you see the menu button? Okay, you see the window zoom, number 4, and then 1 window settings. So what's the minimum x they have in the book? On the page in the book. The x-axis, what's the lowest, the minimum x value? No, the minimum. On the x-axis, what's the number all the way to the left, the minimum one? The low x value in the book, in the graph. -4, so put a x min, use this negative sign here. -4, arrow down, what's the maximum x value in the book? The 4, okay? Then go down to the same with the y's. What was that minimum y value in the book? -10, was it? And they want you to go up to, what was it, 130? And there you go. Enter. Now it looks more like in the book. I thought you were right there with me. Well, hang on just a minute. Huh? Now you want to put that equation in there, right? Push your tab button. You get that come up, right? That's my y equals. And it was 8. Was it 8 times 2 to the x? I think. The top of the page. 8 times 2 to the x, right? So 8 parentheses 2. Get outside your parentheses. And we got to use the caret button here for the exponent. And you see the x and y and z got for the next there. Got that? Okay, so there's our graph. Where is, and before we sketch it in the book, that's the shape of it, right? Definitely nonlinear. You see how the rate of change is increasing, and it gets faster and faster and faster, right? Kinda, yeah, but going up. That's right. You notice here, does it ever reach 0?
Yeah.
No, it doesn't, remember? I heard, yeah, I don't know, whoever. Okay, I mean, it's the resolution on here, you know, it's going to get close and look like it, but it doesn't. Well, what I want to know before I sketch it in the book is what's the y-intercept here?
No, like 9, 8.
Well, let's not guess. How about we trace? Hit menu, trace, graph trace. Hey, it comes right up there. What's the y-intercept?
8.
0,8. So let's go put that in our graph. So, I don't know, probably about there. There's my 8. And I'll just make a sketch of this roughly. It's got to go through there. Okay? I know I missed. It's a little more challenging.
Why you're just saying not 8? Okay, well,
Yeah, we're just making a rough sketch.
I know.
But this is what these graphs look like. This is what an exponential growth graph looks like, right? It's a curved line. Now, quadratics are also curved, right? But these are different curves, yeah? Okay? It never comes back up, you know, on itself. Doesn't make a U. It makes a slide, like somebody said. Okay, so down here. Again, and they're emphasizing the fact that it's all about multiplication, right? We're taking some beginning quantity and multiplying it by some multiple or growth factors, we call it sometimes, okay, the growth factor, and we're doing it some number of times. So A here, what's A in this general form? No,
y-intercept.
the y-intercept of the starting amount, right? The quantity you're dealing with, right? And what is the B?
Base.
Yeah, it's called the base sometimes too, right? That's fine. But the B is the number you're multiplying the starting amount by, right? Like doubling it so it's 2, or cutting it in half so it's a half, right? So that's the number you're multiplying by. It's also the y-intercept, right? Or no, it's not. The A is the y-intercept. My mistake. Oops. So this is the multiple. A is the y-intercept, or the starting amount, okay? And B is the growth factor. And X is the number of times you multiply it, okay? So that's our general form. These aren't that hard to figure out, right? Like if you look at some numbers, you probably say, they could write the equation by saying, oh, what's the starting amount? Well, that's my A. All right, what are they multiplying by every time? That's my B. And there you are, right? So let's go to the next page. All right, so now we have function g of x equals 54 times 1/3 to the x. Is this going to be growth or decay, guys? Because it's getting 1/3 smaller every time, right? Will it ever reach 0? No. It'll get infinitely close enough for practical purposes, like in a real situation, but. So they want us to evaluate g of 0. So that means we put a 0 in for x. Just without even doing it. What does that mean when you put a 0 in for x in any equation? It's, any equation where x equals 0. What does that mean? But what part of the graph is that? Not necessarily. Guys, remember we were graphing and we put 0 in for x, we put 0 in for y, and found 2 points? What were those points that we found to graph a line? The intercepts? Okay, where a graph crosses the y-axis, what is the value of x? 0. Any graph, anytime it crosses the y-axis, has an x value of what? 0. So in the equation, if I put a 0 in for x, the result when I evaluate it is called the what? Y-intercept, isn't it? Okay? Or the starting point, right? So let's evaluate g of 0. So it's 54 times 1/3 to the 0 power. What is 1/3 to the 0 power? Times 1, which equals 54. Do you notice that this 54 is the starting amount? Yeah, I couldn't hear you. That 54 is the starting amount, and we also call it the y-intercept, right? So anytime you put a 0 in for x into an equation, you get the y-intercept, or the initial value. Okay? All right. Now, without using your calculator over there in Part B, evaluate g of 1 and g of 2. Let's think about that. So g of 1, that would mean we're multiplying 54 by 1/3 how many times? Once. So basically it's just 54 divided by 3, isn't it? So it'll be 54. What? Anybody know 54 divided by 3? Oh, let's see. 3 goes into 5 once with 2 left over. 20. So 1, 24. 3 times 8. Yeah, 18, right?
Wait, what's 1/3 to the...
First power, 1/3. Right? So that's 18. How about g of 2? Well, think of it this way. If it's the x is 2, that means we've multiplied 54 by 1/3 once and then again. So really, aren't we just taking 1/3 of 18? So what's 18 divided by 3? 6. Let's just do it this way. 54 times 1/3 squared, which is 54 times, what is 1/3 squared, guys?
One.
What is 1 squared? 1 over, what is 3 squared? 9. So it's basically 54 divided by 9, which is 6. Hey, didn't you tell me that's 18 divided by 3?
Yeah.
Okay. See how it all connects there?
Oh, 9 times 2 is 18.
Yeah. Yeah. All right. Okay, let's go to part C. Graph this thing. We'll make a sketch. And when we sketch it, I do want to at least make note of the y-intercept. You guys see the windows they want you to use?
Yeah.
The x's and the y's? All right, so let's go and put that in. You want to watch me do it and follow along? Or do you think you know how to do it? So let's go back in here. What I want to do first is clear this out. So I'm going to hit menu, actions, and then 4, delete all. That's one way to do it. The other way is I can go up and just delete the equation. Now I'm going to hit menu, undo, settings, and we want to go from -2 to 4, -2, whoops, oh, there already is, right? And then from -10 to 100. Oh, it is, okay. 100. I'll put my, thank you, 54. And remember, it's 54 parentheses 1 divided by 3, get outside the parentheses, to the x power. This graph looks a little different than the one on the other page, doesn't it? You can tell by looking at it, it's definitely not growth, right? Huh? Remember, that's where a variable goes, the next one. You can tell by looking at it, as you read from left to right, it's going down and it's exponential decay. But what's the y-intercept there? Menu, trace, trace. Better move back over. It's like where I left off. It should stop, like at that point of interest there. Yeah. 0, 54. We could have known that anyway, right? By looking at the equation, yeah? Like, did we need to do this on the calculator? We already knew that, didn't we? So we could have gone, so this is like, so this is -10, and up here is 100, and this is -2, 4, and then 54 would be, what about here, probably? And this goes there, like this. Okay, so let's label that as 54. Okay? So let's answer this little file here. Increasing versus decreasing. So let me go back to the first page real quick. This function here was growth, right? What part of the equation makes this growth? The 2, right? Why? Okay, as compared to what part of the equation makes this decay? The thing you're multiplying it by, right? 1/3, okay? So the b, in other words, so the b is what makes a growth or decay. So this exponential a times b to the x will increase or be growth if what? B is greater than 1. Could it be equal to 1?
Yeah.
Well, let's think about that. Take a starting quantity and multiply it by 1 some number of times. Yeah, it's not going to grow or shrink, is it? Okay. Now, this will decrease for what kind of b values?
It's less than or equal to 1.
It'll decrease if it's equal to 1?
It's less than.
Yeah. How about between 0 and 1, yeah? Wouldn't it? How about the -50 then, right? -3, right? Okay. So it'll decrease, let's write it this way, 0 less than b less than 1. But why didn't I include any equal to signs there for the 0 or the 1? We already know 1, right? Because if the thing you're multiplying by is 1, does anything get bigger or smaller? No. Why not an equal to on the 0? Because what? No, you're thinking about what it approaches. The b is the thing you're multiplying some starting quantity by. So why does it not make sense to be 0? Right, what happens when you multiply a starting quantity by 0? It becomes 0. It just stays at 0, no matter how many times you multiply. So we don't include 0 and we don't include 1. Okay? Got it? Okay. All right. What else we got here? All right. We can do this without any calculating at all. They want us to look at these functions, give its y-intercept, and whether it's increasing or decreasing. I will help you with the first one. Don't touch a calculator or anything. What is the y-intercept of this equation? 8, right? And is it increasing or decreasing?
Decreasing. That's the top of the bottom. No.
Yeah, because, well, really, because 2/3 falls in between, is between 0 and 1. That's why. Right? Okay? So it's decreasing. Okay? You guys do these other two. Give me a second. What's the y-intercept for B, guys? 125. Is this increasing or decreasing? Because 1.5 is bigger than 1. What's the y-intercept for part C? Okay. 56. Well, wait, that's a fraction.
It's bigger than 1.
Yeah, it's still greater than 1. 3/2 is not in between, right? It's 1.5, isn't it? So it's increasing. All right. We know what the A is, yeah? What's the A in one of these functions?
8.
No, in one of these. I meant in an exponential function, what does the A represent? Otherwise known as the starting amount. And what does the B represent in an exponential function? The thing you're multiplying by. Okay? Yeah, growth. It's the growth factor, they call it, right? So let's look at this table down here. Here's a table of values for some exponential function. And they want us to write an equation from this in y equals ab to the x form, right? So remember, the a here is the y-intercept, or the starting amount, right? The initial value. And the b is the what? Growth factor, or the multiple, right? The thing you're multiplying by. So let's look at this for a minute. You guys on your own, see if you can look at this table and write the equation that would make it. You just need what the A is and what the B is. So if we look at this here, we see our starting amount here is 10, yeah? So that's our A. That's our initial value. And what do we do to get to this next one? Times 3. And then what do we do? It's multiplied by 3, and it keeps going like that, right? So this is our B, is it not? So the equation has to be y equals 10 times 3. How many times?
X.
X of them, whatever X happens to be. How much to it is there? So basically you guys just did what's called an exponential regression in your head without having to let your calculator do it. The calculator will do these. When I say do an exponential regression, you take data like this, analyze it, right, and generate the equation that made the data. That's called a regression.
Why'd you use 3? Because you're multiplying by 3 every time.
Yeah, you got to, for an exponential equation, you need what you started with and what you're multiplying by every time. Okay? All right. Anybody have any questions on this? We've got a somewhat decent grasp on exponential functions? Okay. All right.